All right, welcome back. MECH1320. We're looking at Chapter 8 in your text. I'm going to go through seals, gaskets, and sealants. All right? So, first of all, what's the point of them? We're going to stop leaks and things like that. But in our systems, what can cause leaks to any of our mechanical stuff? All right? Worn or damaged seals, worn or damaged gaskets, bent or worn shafts, fasteners too tight, too loosen, all right? Elements, all right? Ruin our gaskets, all right? Nicks, burrs, improper installation, right? We learned that maybe if we don't align our belt drive correctly, that ruins things, okay? But, different things like that. So, you have a leaky hose at home, like right where the faucet is, all right? You just got a little rubber gasket that you got to replace. But, the gaskets can fail, so like you see in the bottom right-hand corner there, all right? Just, normal wear and tear, elements, those different sorts of things that go on them. But we have seals for everything, right? What's the purpose? All right, when we have a seal, is to keep the oil in and the dirt out, separate fluids or cavities. So inside our hydraulic cylinders, all right, we have seals, right? Because the cylinder extends and retracts. We need to be able to make sure that fluid doesn't leak from one side to the other when the cylinder is extended or retracted. Okay. We also, have to design them so that they can withstand different pressures and things like that go on. All right. So originally, seals were made from felt and leather and those sort of components here, but now we obviously have upgraded, materials as we get better technologically. Most of our seals are made of nitrile. All right, but we have some special seals that we also make of like silicone and some other similar type elements, right? Rubber, those sort of things. All right, so seals can be spring-loaded, as we see in the upper right-hand corner. Okay, that helps hold form, things like that. Springless seals. We can have single lip seals. So in the bottom right-hand corner picture, we have a double lip, and then we have a single lip on the seals. So, the multi-lip, you might want to see one of these if you ever, replace a toilet in your house. There's a seal between the toilet and your floor, all right? Because obviously you don't want any of that stuff to ever come back up, and you want that to stay airtight so you don't smell it as well. Okay, so we have radial shaft seals, okay? So we slide those between rotating and stationary components, or two components that have that are in relative motion, okay? We have V-ring seals, so you can see a picture of that in the bottom there, all right? We use those to prevent dirt, moisture, and other unwanted material entering an oil or seal housing, okay? So we have that, there's a little flex lip, and that groove, that V, fits in a particular groove too. So you might notice that even if you have a hydro flask or something like that, there's a seal around that at the top. We have CT axial clamp seals, okay? We use them with large shaft diameters, so back on our glow forge, we have that as well to help seal the tube on. The back of your dryer at your house also has something like that as well. Okay, we have HDDF for heavy duty mechanical seals. We use them in heavy construction equipment, right? Those seals are under very heavy load, generally all the time when we're in operation on things like that. Okay, so if we take a look at this spring seal here, all right, where part A is, right? That's the flexible material component of the seal and the lip. Okay, this one only has one lip, okay, and it's the primary sealing lip. So that's, physically contacting the metal, all right, so that if it slides one way or the other, we're kind of keeping fluid from being able to penetrate through there, okay? We have the outer shell of the seal. The purpose of the outer shell is to hold the seal in place or keep its form, right, or have it fit into something, okay? And then we have the garter spring, okay? It's in most. It's just a coil of wire that provides controlled radial load over time, okay? So if there's any sort of radial load, the spring is in there to help absorb it and do that sort of thing. All right, so if we want to do, seal installation, okay? See if it's bent or damaged. Sometimes you don't want to have the lip up or anything like that. You have weather seals at your house. The bottom of your outside door has a seal. There's a seal around the outer of your door, right, to keep the elements from coming in as well. Okay, so generally, sometimes we have it, with a lip and a garter spring towards the fluid or the liquid. okay, when we install that. So these generally need lubrication beforehand, right, because we're touching around metal parts and those sort of things, and we want it to be able to fit and get inside, okay? And then once we do that, we want to use some sort of seal lubricant, all right, and we'll talk about those sort of things toward the end of the lecture here. Okay, very common one, okay, we have as a gasket, all right? Even the back of your computer uses a gasket, you know, to keep unwanted stuff from going into your computer case, where you plug in your mouse and USBs and graphics cards and that sort of thing. But gasket for us, right, it's a pliable material that is shaped and placed between two mating machine parts, all right, to form a seal. So the purpose of the gasket, just like the seal, right, is we want to confine gas, oil, water, vacuum, or exhaust. So, you know, even your lawnmower, you're going to have seals there on the where you take in the outside air and things like that, okay? We want to keep foreign objects out as well, okay? So you don't want anything getting in, anything getting out, all right? So that's kind of why we use, you know, both of those. So you can take a look at some different gaskets down below, you know, and generally a gasket's going to connect in multiple places or things like that. Gaskets have to be able to withstand, you know, heat, cold, pressure, erosion, elements, different things like that, moisture and oil. I mean, eventually, yes, they're all going to fail due to time, decomposing. You have them out in the sun, elements like that, you know, will greatly impact those materials. Okay, but most gaskets, all right, are either made of synthetic rubber, cork, embossed steel. The embossed steel one's more like on your computers and things like that. We also have paper gaskets, all right. But, you know, rubber cork, synthetic rubber, those things are very common. So if we take a look, that's what a rubber cork seal or gasket looks like versus a synthetic rubber gasket. We got an embossed steel one, right? It's got a design that's specifically like placed into it. We have a paper gasket, all right? So if we want to do gasket install, okay, to make sure that everything's laying down properly, in the bottom right-hand corner, there's a picture, all right? Not everything's going to have like 6, you know, things on it, but you always kind of want to go diagonal. It's kind of like doing your, you know, your tires. When you're changing your tire, you always don't do the same lug nut next to each other. Same kind of thing. So if we're doing gasket installation, okay, you want to use alcohol or brake cleaner, right? Because those evaporate quicker than water and things like that, and they don't have the damaging properties as far as what water has, all right? And we can clean them up pretty easy, okay? The surface has to be dry. You're going to apply your gasket sealing liquid sometimes is required, right? Glue to help kind of hold it in place. And then you kind of tighten it in specific steps. So that's the torquing pattern I was talking about at the end, right? It's very similar to, you know, how you replace your tire in your car. You don't always do the one right next to each other. That way you're evenly putting it down so that there's not a slide or a misalignment type scenario that's going on there. Okay, and then just make sure the last step, always torque it to proper specifications. Don't over tighten because you can press that seal down too hard and cause a tear or rip or something like that, and then it's obviously not going to work the way you want it to. Okay, we also have a stuffing box, and we use it to, you know, house a gland seal. So we use that to prevent leakage of fluid such as water, steam, or anything sliding or turning between parts of a machine. So inside a stuffing box, okay, we use a graphite impregnated woven rope. Okay, so we've taken a woven rope and it's got graphite inside of it as well. So very, you know, strong properties and things like that. But we use that as a seal, all right? And you'll see there it is. You can see where the rope is, all right, before we tighten everything, and see how we're in a stuffing box and we're going to seal that in. So we're going to push it in. We're going to push these two parts together, all right, with that stuffing box, and then we're going to go ahead and tighten them. So now we've created a seal, all right, and that seal is inside that cylinder piece where that shaft is going to. So that's essentially what we're using as a stuffing box to seal things. Very common stuff for us, O-rings, all right. You use kind of a flat washer type O-ring in your hose at your house, right? Or on the end of your hose that connects to your faucet so it doesn't leak, all right? So when the fluid hits that, it pushes against it and doesn't allow it to escape. But we have O-rings. They come in several sizes. Most common sizes here are 16th, a 3/32, an 1/8, 3/16, and a 1/4. Okay, different shapes like I said before, okay? O is the most common, but we've got a D shape, a square ring, a modified X. Okay, all these different shapes that we can get them to come into. Just going to kind of, it has to match what we're using it for. All right, the biggest thing, the O-ring, okay? That was a biggest thing. If you've ever watched anything on Netflix about the 86 Challenger disaster, okay, they did it, they tested it over and over and over, and they weren't understanding, why they had an O-ring that was leaking and burning, through. And they did it on multiple tests, and then what had happened is the O-ring was being affected by the outside temperature and had cracked and damaged. So when the Challenger launched, okay, fuel was able to leak and cause the explosion. All right, but it all came down to a simple little O-ring type scenario there. Okay, so we have different shapes to fit different things, and they're coming with different materials as well. All right, because sometimes you're going to have to use a different type of O-ring based on the type of fluid. All right, something that's on a gas can is not going to be the same thing you're going to use for water, right? Because the O-ring, gas can eat stuff up. So you don't want the O-ring, if it gets gas on it, to immediately disintegrate. So we've got to use different properties, depending on the application of where we're using that. Okay? And you can look at where it fits in different designs and things like that. We look at cylinders, the piston rod there in the middle, you can see where those O-rings sit. So when we slide that piston, back and forth, fluid doesn't go from one chamber into another. We also use them to wipe off the rod and things like that as well as it's moving. All right, but keeping fluid in and keeping anything out as well. So if something gets on the rod as it's retracting, okay, we don't want like dirt or dust or those sort of things to get on the inside of that. So we use them to sweep through it, okay, as well. So you can see kind of the inside of the cylinder as we'd have it on the bottom. All right, you can see where there's a piston seal. So that's the one where I'm talking about where we're keeping stuff from going back and forth from chamber to chamber, right, as that rod extends and retracts. Okay, and then we have the face seal, okay, that we can use it as bumpers. We have the trapped seal in there as well that helps wipe things off, clean things as we're extending and retracting and doing those different things. Okay, and you just can kind of see, this is kind of a close-up of what it's looking like as it goes through, all right? We have, it's literally touching the metal, going back and forth. So seals can be damaged over time. Even with lubrication or things like that, wear and tear is going to happen over time just because of the type of material it's made out of, okay? And you can look at the different type of rings and how they fit into there and see how they perform, better ways of sealing. Whether we have, a single point of contact with an O-ring, we have an X-ring that has multiple points of contact, we have a square ring that has a really large point of contact, okay? We also have a delta ring that has a larger, flatter point of contact. So it just kind of depends on, how many points of contact or how wide that contact is, for our seal. Okay, lastly, sealants. All right, so, fluids that we can put in there that are going to, potentially dry or things like that. You use this kind of stuff at your house all the time, with around your windows. All right, you put silicone around your windows. Okay, that helps keep moisture, air, anything else, bugs, all kinds of stuff from getting in. All right, we've got, weather stripping, things like that, the bottom of your, exterior doors, all around the outside of your doors. If you go home and look at the bottom of your outside doors, okay, there's a sealant under there or weather stripping type scenario. Okay, and then, as you close the door, there's generally like a little brown, foamy-like thing that's all the way around as well. Okay, so, but we have different other seals as well, okay? We can use it to hold a gasket in place. We can use some that are aerobic, okay? So those are ones that are going to dry when exposed to air, much like we talk about when we use silicone or things like that. Anaerobic, they cure after the components are put together, all right? So there's certain kind of glues you buy, right? And you take the two different elements, you put them together, and then that reaction, the heat from putting the element together, actually creates the lock as well, okay? So if we talk about aerobic ones that are, affected by drying, an air that you and I have to lead out, right? Silicone, okay, those, we can use those instead of gaskets. We got rubber seals by absorbing moisture in the air. So these are all different ones, okay? But the cure time, you got to read the directions on it, right? Because it always changes with temperature, humidity, size of the gap, right? We're not going to use silicone on like a 1-inch gap over and over, okay? It's not necessarily going to be effective in that scenario. So you just got to think about those things. Then how long it takes them to cure or dry. There's Flex Seal now, all right? All kinds of good stuff. But If we take a look at them, there's different types of sealers. Okay, blue is the most common one. It always comes in black, gray, bronze, clear, red, and white. And we're talking about the package, all right? So that has to do with what you're applying it to. So blue, right, looks like we're putting it on gaskets or things like that. The other one's more just silicone sealant. The other one's going to be high temperature gasket stuff. So, it just depends on the purpose, and there's a little bit more. So you probably didn't know that there's this much to it, all right? If, you go take a look at things, and, whites for a bathroom, right? If you look around your bathtub, you're using this sort of stuff, right? You call it caulk or seal or however you want to do it, right? But anywhere where there's water, you are putting that there so that water does not escape. And you'll look around the bottom of your floor if you have tile or that sort of thing, and you'll be able to see those, okay? So these are thread lockers, okay? So you can use these on bolts that are 1/4 inch or larger. So what are we doing? We're putting this around when we use a thread locker, all right? Technically, we're able to, lock those in. We're gluing, a bolt inside of something so that no matter what, vibration will not allow it to come loose, because between being locked by the threads and the thread locking glue, all right, it won't be allowed to shake loose, because, over time, vibration causes, screws to back out, bolts to back out, all those sort of things. So it's important that we understand that sort of thing, that there are ways we can lock those in place, and that's permanent, right? You're going to get that down on the bolt, and it's going to go down into the threads, and as you twist, all right, it's going to lock it in place, okay? Always apply before assembly on that one, all right? Now, we have the red strength thread lockers, okay? We use those more on studs, okay, and press fits and things like that. Still locks in against heavy vibration, okay? And it requires extra effort to remove with special tools or heat, all right? What will happen is if we don't remove them right if we need to without heat, all right, you might shear the thread before you get it out and do that sort of thing, okay? So we're able to lock those in with red and blue, so those are lockers. So, all right, guys, well, that is the end of this chapter. Hopefully you learned some things about seals, gaskets, thread lockers, stuffing box was, all that good stuff. You kind of see it laying around, but you never really think about it, right? You have your garden hose at your house, you're like, oh, yeah, I got to replace that in there because my hose is leaking. You don't need to throw the whole hose away. When it's leaking at the faucet, you just need to replace your seal. So, all right, guys, well, if you have any questions, feel free to email me or ask in class. Else, I will see you guys in class. Take care.